This is the fourth module within the precipitation type scenarios, and this module is going to talk about the use of the probability of ice present grid. The ProbIcePresent Grid is not a grid that the probability of weather type has automatically populated into the grid system through the forecast builder, and it is a kind of a delicate grid and needs to be handled a little bit differently. The use of the ProbIcePresent Grid is used for situations when a deep cloud process with no ice is involved in the winter time. So for most scenarios, the probability of weather type will assume a deep cloud process, that is ice coming in, that the probability of ice is 100%, and then that ice will fall vertically through whatever layers are present in the environment. So the way to remember the ProbIcePresent Grid is that it's used for the introduction when ice could be lost, or that your confidence isn't 100% that ice is going to be in that environment. Two scenarios there would be the Cedar Feeder mechanism. In this case, you see early on in this scenario here with the sounding on the right-hand side, you see a supercooled liquid layer down below and ice up above. So this ice is not involved in the precipitation process. The second scenario is low-level non-ice clouds, either a scenario where you have a dry slot moving in and a widespread ice loss aloft, or you just have widespread low clouds, basically a widespread supercooled liquid layer in the low levels and no ice production in that layer. So those are a couple scenarios where you want to consider the probability of ice present use. So taking you just through one scenario here, we're going to just look at a situation where a dry layer comes in, basically a dry punch comes in aloft and scours the ice from the southwest. So we start off with a weather grid that has ice pellets and freezing rain, a deep ice cloud process. A warm layer is involved in this situation, and then we're going to have a dry slot come in from the southwest where we lose the ice aloft. So one thing to just take a quick look at, there is no probability of refreeze sleet grids right now. Those are 0% probabilities. And we're going to move into the forecast builder to edit these grids, and we're just going to look at the afternoon period here. We'll move into today, and we're going to go to the top-down grids. The ProbIcePresent is one of those top-down grids. So those top-down grids will load in here. We're not going to repopulate it this time, although you do have that possibility. If you'd like to load a blend of ProbIcePresent, you could do that. So there's the warm layer aloft. You notice over the southern portion of the forecast area, we have a warm layer aloft greater than about 2 to 4 degrees. And that currently there's no probability of ice present grids in the GFE for the afternoon period. So we're going to create a probability of ice present grid. And just a reminder that in the short term at least, you do have the RAP 13 available to look at the probability of ice present, and the NAM and GFS are there as well. But I would highly recommend the RAP 13 as a first guess when you're looking at probability of ice present. So we're going to just draw a probability of ice present grid for this scenario. We're going to have a 0 line, and then we're going to draw a 100 line so that we see the dry punch coming in across eastern Iowa, northern Illinois, and southern Wisconsin. So there's that grid. Let's take that and just expand it for the afternoon period to make this a fairly simple scenario, so you can see the impact on the other grids as we run through the forecast builder. Now let's click OK and move on to the next step of the forecast builder, looking at the precipitation types and calculating the probability of type grids, as well as the snow and ice sleet amounts. You notice at this time we do have a sleet grid in the southern portion of the forecast area of 100%. And now that ice scouring, that dry punch, is going to come in from the southwest and have an effect on that probability of sleet grid. Probabilities of snow are off to the northwest in a little bit cooler air there. You can see they're fairly small already in that dry punch area that we drew in. So there probably won't be much change there. So let's go ahead and rebuild the probabilities. I suppose before we do that, we'll just see what the snow amount looks like quickly. You can see there's very little snow over the south, and of course that includes sleet, so there's about 1 inch of sleet there, somewhere between 1/2 to 1 inch of sleet. So we're going to click on OK. The probability of type grids are made. The snow and ice accumulation grids are made. And let's just take a second and inspect those. First, you can see that the probability of sleet was really zeroed out basically across most of southwest Wisconsin and eastern Iowa because of that dry punch coming in. We no longer have ice introduced into the warm layer, so there's no change of phase. It's an all liquid solution when we have a low probability of ice present grid in there. Same thing with the snow, although there wasn't as much of an impact, but you can see the zeros to the southeast. And freezing rain, it all became a freezing rain scenario across southern Wisconsin and eastern Iowa now underneath that dry surge. Snow amounts have all been zeroed out, and now we have more of an ice accumulation. It depends on what your QPF is. Typically, these are low precipitation scenarios when the dry punch does come in, unless you can generate convection over the top of that supercooled liquid layer, but most likely you'll be editing the QPF down as well. So we step through, we're not going to edit any non-precipitating grids right now, type grids, and we're just going to make our weather grid now. And you can see now that there's a fairly large expanse of freezing rain across the area that the dry punch is coming in, and then we transition over to snow in the deeper ice cloud layer off to the northwest, possibly in the deformation zone there. So that's just an example of how the ProbIcePresent grid would work in a scenario like that, where a dry punch would be coming in from the southwest. The other situation you could have is the Cedar Feeders situation. So let's try to replicate this sounding environment that you see here. So we're going to start off with a supercooled liquid layer near the surface. A dry wedge of air is above that supercooled liquid, and then you have ice production aloft. But with time, the ice production continues, and we continue to saturate. And so eventually that ice layer is going to make, those ice crystals are going to make their way into the supercooled layer. You notice that it is all below 0 Celsius in this scenario. So you're going to go from a drizzle freezing rain scenario into an all snow scenario. So let's replicate that in the GFE. We jump into the forecast builder. We're again going to go to the afternoon. So we'll click on today. Jump into the top-down grids. So you notice here we have a probability of ice present 0 over the southeast part of the forecast area, very similar to the scenario we just moved through. And what we're going to do is we're going to basically slowly just saturate that layer within 2 hours, much like the lapse sounding environment that we saw in this scenario. So we basically made 2 grids and just interpolated those. It is in a scenario where the max T aloft is above 0, but also cooling. So instead of a liquid solution now, we'll see some of the different types, especially snow, make its way into the forecast. There is no probability of refreeze sleet grids, or at least they're there, but there's no probability that's above 0. So let's just click on stratiform and rain. Let's look at what the probabilities look like before. You notice the freezing rain scenario here. This is what we've got for this scenario, and then as the ice makes its way into the ProbIcePresent grid, grows to 100% through those early hours, we move to an ice solution. So we start, same thing with the probability of sleet there. We start with 0, and in those couple hours we move over to utilizing the full top-down grids because the probability of ice is growing, so we now have a full deep cloud process. So we'll move through the top-down weather, we'll move over to the weather step, create the weather grids, and we'll see the outcome there for moving our ProbIcePresent grid from 0 to 100% over the course of 2 hours as upper level ice is created and it now interacts with that lower level supercooled liquid layer cloud. So now the weather grids are complete. You notice we have freezing rain in the beginning part of the afternoon at that 18Z grid. Now we're going to step through. That's a half and half split there, 50% probability basically of ice present, and then all ice present with time. So you may ask yourself why we don't populate the ProbIcePresent grid all the time in the probability of weather type grids. Well, one of the big conundrums that we're facing is that in a dry air mass, if you just imagine just a totally dry air mass, precipitation free, the ProbIcePresent is actually 0 in that environment, right? Because the relative humidity is so low that we're not generating ice, and so the probice would be 0, and it would really lead the probability of weather type towards a bias of freezing rain and freezing drizzle. So one of the situations you have to watch out for in the probability of weather type is having a ProbIcePresent grid populated behind precipitation events, behind a precipitation shield where you're actually drying out the environment. Because on the very edge of the precipitation shield, you'll see freezing drizzle and freezing rain show up if you have that probability of ice present grid there. A general rule to remember is once the atmosphere is producing a deep cloud process, where ice is being initialized and falling through the depth, you don't need the ProbIcePresent grid present at all in the grid infrastructure because the probability of weather type assumes this 100% ice introduction. So when precipitation ends and we carry a pop that's greater than 15%, that's when this scenario can show itself if you have a ProbIcePresent grid. So let's show an example of that. We'll go to the forecast builder, and we're going to work on a tonight period here, and we'll just go into the foundational grids. And we're going to look at the evening grids here and notice the probabilities are really dropping off as the storm system moves away during the evening hours. Our pop grids are dropping off overnight. So let's move on to the top-down grids now. We're not going to initialize any grids, but we're just going to visually inspect the evening grids. And we notice we have ProbIcePresent grids as well as max T aloft grids. Our max T aloft is all below 0, so -2 basically. And then notice our ProbIcePresent grids are diminishing as well. It's this area of 0 on the back side of the precipitation shield that's going to cause us some problems in the precipitation type outputs that the derived weather grid will hold. And it's always good as a general rule also to check your road temperature grids to make sure that you don't have any road temperature grids in there. That can sometimes sneak up on you. So we're just going to remove those. We're now in step 4, and we're going to do a stratiform precipitation type. We'll use freezing rain, that's fine, and we're going to rederive our precipitation probability of type grids for the precipitating elements here. And then do a quick inspection of those to show you the example here of what we're talking about. Notice the ice accumulation here on the back side of the cyclone. And freezing rain during the evening hours. Notice how the ProbIcePresent's moving in from the west of zeros, and that freezing rain shows up. Probability of freezing rain on the western side of the cyclone. We're going to fly through step 5 and go and look at what the weather grid looks like. And so here we're recreating the weather grid. So here we're starting our weather grid with all snow, but as the cyclone moves away, we start to see these backside freezing rain weather types coming in because of those freezing rain probabilities. So The whole idea here is that once you go to a deep cloud process, do not include a ProbIcePresent Grid in your infrastructure. Just remove them. So let's just move to the top-down grids and try to fix that. We'll go to tonight, and we'll just run it through tonight, obviously. For top-down grids, we're just going to go in and pull out those probability of ice present grids. Save them. And then just move on and rerun all these probability of types again. We'll use stratiform and rain. And now you notice that there's no, the probability of freezing rain grids are not even existent there in the afternoon hours. We'll keep going into the non-precipitating types. We don't need those, and then we're just going to remake the weather grid, and you'll see the final result. And here's the final result of the weather grids. You see no freezing rain in there at all. So that concludes the probability of ice present module. I do have one larger picture item to remind you of, and that is you should collaborate. Your level of collaboration should occur on the top-down grid level. So when you're looking at your top-down grids, your max T-loft, your ProbIcePresent, and your probability of refreeze, you should collaborate on that level, because all the grids that you see within this red box, this salmon-colored box here, are all the grids that fall out of those top-down grids that you're going to edit. So remember, everything downstream of the top-down, all these different grids are derived. And so it's important that you spend some time collaborating those grids to get your final outcome to match up, especially your snow amount and ice accumulation grids. All right, that concludes this module.